Welcome back. In the last video, we went over the documentation for the enhanced input system in Unreal Engine 5 and learned a little bit about how it works and how we can add it to our project. Now we're going to talk about how we can get a project converted from the old input system to the new enhanced input system. So we'll start with a really basic example. In this project, I have a pawn. It's called BP Bird. I have it here in my Content Blueprints Pawns folder. And if I open it, I see that it's just a basic pawn. It has a capsule component and it has a skeletal mesh component, and it's called Bird Mesh. And I don't even have an animation blueprint. It's just set to use a single flying animation. Now, this bird is using the old input system. Currently, I just have a single form of input, and that's to press a key and log a message to the output log. So if I open my output log and dock it in the layout, I can press play and possess this pawn because, as you can see in its details panel, it has auto possess player set to player 0. So we don't even have a game mode set for this level. We're just auto possessing this bird pawn, and if I press play, well, we don't even have a camera and spring arm, so we can't see that we're possessing the bird pawn, but I'm logging a message to the output log, and if I click in the viewport and press the W key, I see that I'm logging a value of 1, and if I release it, I'm logging a value of 0. And if I shift F1 to get my mouse cursor back and detach, well, then I can move and see that I am indeed possessing this bird pawn. We just don't have any offset because we haven't added a camera or spring arm component. This is super basic. And in fact, it doesn't even move forward. We're only pressing the W to print a message to the output log. Now, in the old way of handling input, we would go to Edit and Project Settings and select Input, and we would add axis and action mappings. As you can see, I have just a single axis mapping called Move Forward, and if I expand it, I have the W key linked up to it. This is the old way, and I would set it up in C++ as follows. In my bird header file, I would have some sort of callback function that takes a float. In this case, I have a function called Move Forward, and I would bind it to that Move Forward axis mapping. So in my C++ file, I would go into Setup Player Input component. Don't mind the red squiggles, that's just IntelliSense struggling to keep up with me. But as you can see, Setup Player Input component has this Player Input component, which has a bind axis function, where we would select the axis mapping name. And to remind you, here in the engine and project settings, its name is Move Forward. So we've bound that. We have a user object, that's this, because this bird is the object that we wish to call a function on, linked to this axis mapping. And we have a callback function. We're passing in the address of a bird move forward. And as you can see, my move forward function is really simple. All we're doing is using UE log to log the value of this axis mapping to the screen. So this is all the old way of using simple player input to do something in the game. In this case, we're logging value using a UE log. So how would we get this converted so that we're using the new enhanced input system rather than the old way? Now, if you haven't watched the first video where I go over the documentation, I highly recommend you watch that video as it explains all of the enhanced input system concepts and how they work. And that'll give you a good grasp on what we're about to do in this video. And in that video, we learned from the documentation that to use enhanced input, we have to add the enhanced input plugin. Now, if I were to convert this project into Unreal Engine 5.1, then that will do the trick for us. This is currently a 5.0.3 project. So if I convert this to 5.1, then I don't have to enable that plugin. It'll be enabled by default. But if I were to stay in 5.03, I would go to Edit and Plugins and search for Enhanced Input and check that and restart the editor. And then the enhanced input features would be added to this project. So converting to 5.1 is an option. or just adding this to an older version that has enhanced input in the plugins menu is another way. Now, I'm going to convert this project to 5.1. So I'm going to close all. I'm not even going to save what I did. And I'm going to close the Visual Studio solution as well. And I'm going to take my project, it's called / in my case, right-click on the U project, and select Switch Unreal Engine version. And I can select 5.1 and click OK. Now, as soon as I do that, I'm just going to open my /.solution in Visual Studio and make sure we can successfully compile. So we'll go ahead and Control-Shift-B to compile our solution. I'll pull up our output log here, and I see that I have a successful compile. So what I can do is I can now launch the editor. So I'm going to double-click my .u project. Now, as soon as it opens, I get some messages that say upgrading default player input class to enhanced player input, and another message that disappeared before we could read it, but I'll show you what those messages were showing us. If we go to Edit and Project Settings and click on Input, well, some things have changed. The first thing we see is that axis and action mappings are now deprecated. Please use enhanced input actions and input mapping contexts instead. Now, we talked about what these are in the previous video when we went through the documentation. Now in 5.1, these are deprecated. It doesn't mean they don't work anymore. The old way still does work, but they're deprecated, which means in a future engine version, eventually we'll have to use enhanced input. Now, if we scroll all the way down, the default classes have changed. They used to be player input and input component, but now they're the new enhanced versions of these. This happened when we converted to 5.1 because now 5.1 has enhanced input enabled by default. Now, the reason the old way still works is because these are child classes of the old classes, so they inherit all the capabilities, including being able to use these action and axis mappings. But of course, these are now deprecated, and we're going to learn how to do things the new way. So now we have access to enhanced input. And again, if we go to Edit and Plugins, we can search for enhanced input, and we see that enhanced input is checked. This plugin is added for us as soon as we upgraded to 5.1. So we don't have to add it and restart the editor or anything like that. The enhanced input plugin is already here now. So what we want to do is convert that basic move forward input system that we created so that we're using enhanced input. Now, I don't see my bird pawn here. That's because this is the minimal default level. It's going to reset back because this is a level from engine content. We could save it as a new level and put it in a new location if we want to save the changes we make. But really, I can just drag in my bird pawn, and if I search for auto possess, I see that it's set to player 0. So if I press play, I'm possessing it and I'm getting that message logged to the output log. So we see that the old way of input still works. I can press W and I'm logging 1 or 0 based on whether or not I'm pressing that W key. So our goal here is to now use enhanced input instead to get the same behavior. And I know this is basic. We're going to get into more complicated input later on. But for now, let's just get this basic mechanic working, this logging to the output log. So I'm going to close the output log. And as we learned in the last video, instead of axis and action mappings, which is the old way, as we can see in project settings and go to input, we see we have a move forward axis mapping. Instead of this, we're now going to use an input action. That's the enhanced input actions that this yellow message is talking about. We need to make an input action for our bird. So what we can do in our pawns folder where I have BP bird is I can right click and I can add a new folder, and I'm going to call this input. We'll put our enhanced input classes in here, and here is where we're going to create an input action. And we can do so by right clicking, going to input, and selecting input action. And I'm going to prefix it with IA, short for input action, so it's clear that this asset is an input action, and I'm going to call this simply move. So I can double click on IA move, and here's my input action. And we see that its value type is digital bool by default, which means that it can handle either true or false type of information based on inputs. Now, We're going to keep this nice and simple and leave it at bool just for this example before we move on to handle actual movement. We just want to link this up with our character and make sure we can use this IA move and find out how. Now, creating the input action is step 1. In order to link up this action with a particular player, and we say local player because in a multiplayer game there could be multiple players in a game, the local player is the one on this machine controlling this pawn through that player controller. So we need to link up this IA move to this local player. Now, in order to link up our IA move input action to the player, we have to make an input mapping context. And to do that, we can simply right-click in the content browser, go to Input, and select Input Mapping Context. Now, I'm going to prefix this one with IMC, short for Input Mapping Context, and I'm going to call this Bird Context. This Input Mapping Context can have input actions added to it. And we're going to do that now. So we're going to open IMC Bird Context. And up here we have mappings. So now that we can add input actions to different input mapping contexts, we now no longer have to go to the project settings level and set up inputs for the whole project and then go into code and make checks based on gameplay logic to determine what those key presses do. Instead, we can use separate mapping contexts and activate or deactivate them at runtime during the game to change behaviors linked up to certain keys. Now, in order to use IA move, we have to add it to our input mapping context. We do that by clicking the plus next to mappings, and if we expand the dropdown, we see that it says none here, but if we click open, we can search for our input action called move. It's IA move. If we select that, now we have the option to link up different keys to this input action. Now we can do so by selecting keys from the dropdown, but there are a lot of options here. We could go to keyboard, choose the tab key or the enter key or the number keys. But a handy shortcut is to simply click this icon next to the dropdown and pressing a key on the keyboard such as W, and now we've linked up W to IA move in this input mapping context. Now, input actions can have triggers and modifiers associated with them, and we discussed those in the last video. For now, we're going to leave this input action without any triggers or modifiers, as we just want to get this working. And we saw from the documentation that we can link up this input mapping context by associating it with a specific player controller. We can do that in our bird's blueprint. I'm going to go back into my pawns folder and open BP bird. Here's my bird pawn blueprint. And if I go to the event graph, I can use begin play to get our controller. So I'm going to get controller. And let's see if we can cast this to a player controller. As the docs say that to add our mapping context, we need to get a player controller. I'm going to cast to player controller. Drag off of begin play, and if the cast succeeds, I'm going to print a string that says cast succeeded. And if I press play, there I see cast succeeded. So we can get our controller from a pawn and cast it to a player controller because this get controller function returns a controller. In C++, it would return a controller pointer. But even though its data type is controller, it stores an actual player controller, and we have to cast to get that player controller. So now that we know we have a successful cast, the docs say that in order to link up our input mapping context to this controller, we have to get something called the enhanced input local player subsystem. We get that directly from the controller. So from our cast, we can search for enhanced input and call this function get enhanced input local player subsystem. Now this subsystem has the functions for adding input mapping contexts, removing them, and so on. And to add one, we call the function add mapping context. So we'll call that and hook this up. And for this function, we'll simply select the mapping context. Ours is called IMC bird context. And we can give it a priority. If we give it a priority, then We can have multiple mapping contexts added at the same time, but the priority will determine which input actions will work, and we won't have any collisions between input mapping contexts. And we saw that in the previous video as well. So now that we've linked up our mapping context, we need to decide what happens if this input action called IAMove gets triggered. Now, as soon as we made IAMove, an event was generated for us, and we can access it in BP-Bird. Its name is the same as the action mapping, so we can search for IAMove. And here under Enhanced Action Events, we have an event called IAMove. We want the one with the arrow, not this one down here. That's an actual value of an enhanced input object. We want the event that was auto-generated for us as soon as we created that input action. And as soon as this action is triggered, well, what we can do is we can print. Now, we can use print string if we'd like, and notice that our event has an action value, and it's a Boolean. That's because when we created the input action, we let its value type be bool. But as you can see, input actions can handle float values by choosing axis 1D. They can have two-dimensional inputs, like a two-dimensional vector. So it would have an X and a Y axis, and it can have a three-dimensional vector. Now, we left it at bool, which means when our input action is triggered, if we simply drag action value into the print string, we'll get a conversion from bool to string, and we should be able to see the value that our input action has once that action is triggered. And that value will be true or false based on whether or not our W key is pressed. That's because we linked up the W key to IAMove. So if we go ahead and press play, click in the viewport, and press the W key, we're printing true to the screen. And if we release, we don't see false because we're not triggering that input action. It isn't being triggered until we actually press the key. And if we hold the key down, we see that it's being triggered every single frame, and we get that print string. Now, this is a little bit redundant because if I remove that print string, if I just unhook that node, and I go back and press play, we can actually see the value of our input action by using a console debug command. We saw this in the last video as well. If I hit the tilde key and type show debug, enhanced input, well, now we see some debug on the left, and we can see our context is set to IMC bird context. I'm actually going to Shift F1 to get my mouse cursor so I can point this out. We see that our player is player controller 0. That's the only player controller in the game right now. Here's our IMC bird context currently added to the enhanced input local player subsystem. And here's the only action that this context has. It's called IAMove. It has a value of none and a duration of 0 seconds. And here's the key assigned to it. Now, if I click back in the viewport and press W, all of a sudden it says triggered. And I'm holding W. And it's keeping track of how many seconds have passed since IAMove has been active. And W says true because that's the value that this input action has. And if I release, now it says 0 seconds with false. So this is a really useful way to debug and see if our actions are working. So we don't need to resort to print strings or UE logs anymore. Now, let's say we want our own functionality in C++ instead. So this is the blueprint way to do everything. Let's do it in C++, and we can use a UE log. So rather than using this auto-generated event, let's say we want our own C++ function to be linked up to this IAMove input action. So let's do that. I'm going to go back into my C++ project. Here's my bird.cpp and my bird.h. Now, the old way of doing things was to create a void function that takes a float value whenever we wanted to bind a function to an axis mapping, because axis mappings receive raw input and provide us with a float that'll be 0 if the button is pressed and 1 if the button is released, and so on, right? Let's do this the new way. Now, to set up enhanced input from C++, we have a few extra steps. And before we set that up, let's just take a look again at what we did in Blueprints. We got our controller, right? We cast it to a player controller, And from that player controller, we got the enhanced input local player subsystem. We're going to learn how to do that in C++. And we called add mapping context. And when we added a mapping context, we needed to provide an input mapping context. Now, the blueprint node lets us hard code one. We can select any input mapping context that exists in our project. From C++, though, this function also requires a mapping context. So where are we going to get that value in C++? Well, we could create a variable, make it edit anywhere, for example, and set it in the details panel of our bird. Let's do that. So here in bird.h, we're going to add a variable for our input mapping context. And the C++ type for an input mapping context is uInput mapping context. So this will be a pointer, and we're going to call it bird mapping context. Now we see that it's a undefined type. So that means a couple things. For one, we're going to want to forward declare it here in the header file. We've already learned why we should forward declare rather than include headers in other header files if we can help that. So up at the top, I'm going to forward declare uInput mapping context. So now we can use this type even though its header isn't included. It's now just an incomplete type. Once we actually use it in the CPP file, we'll have to include the header where this is defined. Now I want to be able to set this input mapping context from the bird blueprint. So I'm going to make it a U property, and I have this in a protected section. So I can make it edit anywhere if I'd like to set it from the blueprint in the details panel. And if I did want to access this from the event graph, I could use blueprint read write or blueprint read only. I'm going to make it blueprint read only. Since it's not a private variable, but a protected one, we can use that specifier. And I'm also going to place this in a category. We'll place it in the category input. So after adding this variable, I have to remember that this will just be an empty pointer until I give it some value, and we'll do that in the blueprint details panel. And we can do that thanks to edit anywhere here. So we can add this bird mapping context the same way we did in blueprint by first getting our controller, casting to a player controller, and getting the enhanced input local player subsystem and calling add mapping context, passing in the mapping context and the priority. Let's find out how we can do that. We'll do it in begin play, just like we did in the blueprint. So in bird.cpp, we can go to begin play, and the first thing we can do is get our player controller. So we're going to say a player controller. We'll make a local pointer of this type, and we'll call this player controller. And we'll set it equal to the result of a cast. Now, we're casting to a player controller, so we're going to take that type and place it in the angle brackets. And what we're casting is what we get from our controller. Now, pawns have a controller variable, which we can access directly. So even though in blueprints we used get controller, here in C++ we have direct access to that controller variable. Now, it is possible in the future that they may move this into a private section in the base class where it's declared, in which case we would have to use getController, which is an inherited function that simply returns that controller. So we can be preemptive and use getController just in case they ever make controller private. And Unreal Engine does tend to do that with some inherited variables. It'll move them into private sections, and then in child classes like our bird class, they would be inaccessible and we'd have to replace them with the getter anyway. So anyway, now we have the player controller, right? And as long as that cast succeeds, we'll have a valid pointer that we can use to access that subsystem. And we can always check player controller with an if statement to make sure that we don't try to access it if it's null. Now, if you watched the previous video, you might have noticed that the third-person template project does this a little differently. Let's look at how the third-person template project does it. Here's the third-person template project. I just created a project called Enhanced Input Project, and it made this character for me. And in Begin Play, in the third-person template, it does this way. It has an if check, and it creates a local variable inside of the if check, setting it equal to the result of the cast. It's casting controller to a player controller. Now, this might look a little bit confusing, but really it's only doing one thing. It's creating a local variable just like we did in our bird class, only it's declaring it in the if statement, parentheses, and that just means that this local variable only exists in the scope of the if statement. If I were to, say, go outside the if statement and type player controller and try to call a function on it, well, it doesn't exist anymore. It goes out of scope as soon as this if statement body has been ended. As soon as we exit the if statement body, player controller is no longer valid. That pointer gets destroyed. Not what it's pointing to, but the pointer itself, and we can't access it. Now, the way we did it in BirdPawn, we created the player controller local variable outside the if statement. Therefore, it's still in scope until we reach the end of begin play. We could type player controller down here, and we can access functions on it because we created it outside the scope of the if statement. If we declared this variable inside the if statement, like the third-person template project does, then it will only exist in the if statement and go out of scope here as soon as we exit the if, instead of here when we exit begin play, as is done here. So if we wanted to make this a little bit more like the template project, we could move this line here into the if statement like this, and then player controller will only exist here in the if statement. We can access functions on it and use it, but we cannot access it outside the if statement, as by that point it's gone out of scope. So I just thought I would explain that. Now in our blueprint, after casting to player controller, we need the enhanced input local player subsystem. We can even see how it's done in the third-person template project. Again, they're using this trick where they're declaring a new local variable, this pointer here, inside this second if statement. So that means this subsystem local variable is only in scope here inside this second if statement. If we tried to use it outside that second if statement, say to try to call functions on it like this, well, it's out of scope by the time we exit that inner if statement. Now, if you're wondering why they did this, it's a very, very minute form of optimization. You see, if this pointer is cleaned up or deleted as soon as it's no longer needed, well, then we can do other things in begin play and have one pointer's worth of memory freed up for the rest of the function. But nonetheless, all that's happening here is a new local variable of this pointer type is being created, and it's U enhanced input local player subsystem. They're calling that local variable subsystem, and they're initializing that pointer by getting the enhanced input local player subsystem. They do that by accessing the uLocalPlayer static function getSubsystem. This is a template function which requires you to specify the type of subsystem. Subsystems are a type of class that can be used in Unreal Engine. Enhanced Input uses this particular class. Now, it's created by default when you start playing the game. So if we call getSubsystem, specifying this type with the Enhanced Input plugin active, we should get a valid value from this. And getSubsystem requires a uLocalPlayer. So we typically talk about the player controller or the controller when we're talking about a player, but there's also a local player class associated with the player playing the game as well. And we can always access the uLocalPlayer associated with the player controller with getLocalPlayer. So what we're doing is calling getSubsystem, passing in the local player. This is a little different than what we did here when we called add mapping context, as Blueprint already takes care of figuring out the local player, whereas here in C++, we have to specify the local player. We get that from the player controller. So we're going to do this same thing in our project. So first we need our U enhanced input local player subsystem. So we'll say U enhanced input local player subsystem. That's a pointer. We'll call this subsystem. Now, right away, we get red squiggles because, well, we're using this class, and we need to include the header file where this is defined. Otherwise, the compiler doesn't know what this type is. So I'm just going to copy this type And we'll go straight to the engine docs. In fact, I can just type into Google UE5 with this type, and the first thing that pops up are the Unreal Engine docs for this type. And we can see that not only is this in the enhanced input subsystems header file, so we can copy that, but it's also in the module enhanced input. Now, I know that we have this plugin active on our project, but to access these header files in C++, this module needs to be added to our build file. So we'll take care of those things. First, we're going to comment out this line, and if we go up to the top and we try to include enhanced input subsystems.h, we get an error here. We can't open that file. That's because, again, this is in that module called enhanced input. We need to add that module to our project's build file. So again, let's comment that out. We don't want any errors there. And in our project, we have our build.cs. Now, my project is called /, so the build file is /.build.cs, and here are all the modules being used in it. Now, you don't have to understand C#. That's what language this CS file is in. All you have to know is that when you build your project, these modules are added to the project by default because we're specifying them here. That's why we can access engine classes and header files that exist in these modules, because the build file determines which modules to include. You see, Unreal Engine is a very large engine, and it's made up of a whole bunch of different modules. You can expand the folders here under Engine to see a whole bunch of modules. Here's the plugins folder. All the plugins are modules. And the way to include those header files is to include the modules here in the build file. We want to include enhanced input, so we're going to add a comma to this list and type in quotes enhanced input to include that module. Now, let's go ahead and compile after adding enhanced input to the public dependency module names. And to compile from Visual Studio, because I have live coding enabled, I'm going to close the editor first and then compile my Visual Studio project. We have a successful compile, and with enhanced input added, we should be able to go back to bird.cpp. For now, we can uncomment enhanced input local player subsystem and see that this type is recognized. We successfully included enhanced input subsystems.h, and now we can create a pointer of this type. So I know that was a lot of work just to create a pointer of this type, but now we have access to the enhanced input module on the C++ side, and now we can use those classes. So looking back at the third-person template project, we see that we initialize subsystem by getting the U local player and calling get subsystem, specifying this type in its template and passing in the local player. So we'll do that here. We'll set subsystem equal to U local player, and we'll call the static function get subsystem, and in its angle brackets, we'll pass in U enhanced input local player subsystem, and in the parentheses, we need to pass in the local player, which we can get from player controller, and the function is get local player. So we'll add that semicolon there, and now we have the subsystem. And we know that we should check pointers before we use them, so we can say if subsystem. And again, if we want to use this trick where we declare this local variable in the if statement, therefore it will only exist in the scope of this if statement, well, we could do what the third-person template project does and declare and initialize this variable all inside of the if statement here, like this. Now, you might be wondering, how does the if statement succeed or fail? Well, this comes down to C++ syntax and the mechanics of how the language works. We're creating and initializing a new pointer. So what does this whole expression return for the if statement? Well, when you declare a new variable such as a pointer, then the return value of the entire expression is the pointer itself. So this is the same as saying if subsystem. And if all this stuff on the right side of the assignment operator returns a valid pointer, then if subsystem will succeed and will have a valid pointer. But we get the same result if we were to declare this variable outside the if statement and simply check the pointer directly. The only difference is this is now only in the scope of the if statement in its body here. So we did all that work just to get the enhanced input local player subsystem. And we can remind ourselves of what we did in blueprints by opening BP bird again. And here we got that subsystem, and from that subsystem, we called add mapping context. We can do this in C++. So we'll do that by taking subsystem and calling add mapping context. Here it is. And if we open the parentheses, we see that it takes a U input mapping context. It also takes a priority. And then we have some modify context options. These are optional. There's a default value, as we can see, so we don't have to pass that in. All we really need is the input mapping context and a priority, which is an integer. Now, we added a variable called bird mapping context. This is a U input mapping context. We can pass that in for the input mapping context. So we'll pass it in here. And for the priority, we'll just pass in 0, just like we did here in the blueprint. Here we're hard coding it. In C++, we're passing in a variable. And there's the priority, and there's those options, which again are optional. Now, we made this a variable, right? If we go to BP bird self and search for the input category, here's our variable bird mapping context. It's set to none. We never actually initialize that pointer, but we can set it because it's edit anywhere. So we can select IMC bird context. So now we'll know that once the game starts, we've set this to a valid value, and this pointer, bird mapping context, has a valid value because we set it in the blueprint. So all that work just to get the same effect as this logic here in event begin play. So now that we're already doing this in C++, we don't need to do it in blueprint anymore. Now, the last thing to do here is to have some sort of function that can be linked to IA move. Again, things are easier in blueprints because this event was created and it's already linked to that input action. But we want a C++ function linked to IA move instead. So let's do that. Now, to do that, we're going to add a variable for that input action called IA move. Now, in C++, an input action has the type U input action. So U input action, it's going to be a pointer, and we can call this move action. Now, this is just an empty pointer, right? Just like bird mapping context. So we want to set our move action to the input action asset that we created in the editor. So we're going to make this edit anywhere as well. We'll go ahead and make it blueprint read only and put it in category input also. So now that we have a U input action variable, we can use it to link up a C++ function, which means we'll need a function to call. Again, in blueprint, we didn't have to make a function because this event was created for us as soon as we made that input action. But in C++, we need to make our own function. So we can make a function. It's going to be void, and we can call it move. Now, in the old way, we used a float called value. The new way is a little bit different. The new way takes a different type of input. And we can see that by, again, looking at the third-person template project. It has a move function as well. It's right here. And look at its input type, F input action value. This is a struct that contains information about an input action. This makes it much more versatile because input actions can hold booleans like our IA move that we created, but it can also hold two-dimensional vectors, three-dimensional vectors, or even one-dimensional vectors. And so this way, if we make a callback to link up to an input action, we only have one function signature that we need to worry about, one that takes this F input action value, and it's passed in by const reference. So we're going to use that as the input parameter for our move function. So it'll be a const reference of type F input action value. There's the reference, and it's called value. And we can make a function definition. And now we have a function. So in Blueprint, we had an event, but in C++, we're making a function. Now at this point, let's go ahead and compile our solution, which means I'm going to close out the editor, clicking Save Selected. And here in Visual Studio, I'm going to go ahead and hit Control-Shift-B to compile. And we see that we have a failure to compile. Now, why is that? Well, we have a couple of issues here. For one, missing type specifier int assumed means it doesn't really know what an input action is. Well, we can easily forward declare uInput action, just like we did uInput mapping context. So we'll forward declare uInput action here. So that takes care of that type. But we also have some issues with line 35, which is now 36 because we added that forward declaration up there. And that's referring to the compiler not knowing about this type. Now this is a struct, and we can't forward declare something that's not a pointer. This is not a pointer. But structs in Unreal Engine are typically small, and it's generally safe to include their headers here in the header file. In fact, look at the template project for the third-person template. Scroll up to the top of the characters.h file, and there's the input action value header. So we can see that even in this example, Epic was okay with including this header here in the characters.h file. Since we now know that this is the include for that struct type, we can copy it and we can add that include here to the top of bird.h. But we have to be careful. If we're including a header here, it has to be above the generated.h. Remember, that has to be the last include in the header file. So now let's go ahead and try to compile. And now we see that we compile successfully. So for these pointers, we can forward declare, but for this struct, f-input action value, we need to include the header file because we're not forward declaring. We can't forward declare if it's not a pointer. So now that we have this move function, we want to make sure that it's working, right? And in the old way, we just had a value of float type, and we were able to print that to the screen. But now we have an f-input action value. So how do we get the input actions value from this struct? Well, we can take that value, and being a struct, not a pointer, we can use the dot operator. And f-input action value has a get function, and this is a template function because, well, this system was made versatile to handle multiple types of inputs. We can use bool here. If our input action used a 2D vector, we could use f-vector 2D, or if it used a three-dimensional vector, we could use f-vector. But in this case, we know that our IA move has the bool type, so we're going to use bool. So by calling value.get, specifying the type bool, we can get this input action's current value. And we can store this in a local variable. We can make a const bool called current value, for example, and we can initialize it. And we can print to UE log if this value is true. Let's just say if current value, then we'll use a UE log. We'll say UE log temp warning. And for the text, we'll say IA move triggered. So now we have a function that we wish to bind to our IA move input action. The only thing that's left is to actually do that binding. And we do that in setup player input component, just like in the old way of doing things. In the old way of doing things, we took the player input component, which gets passed into this when this function is called. It's called automatically and it's called once. But now things are different. Now our class project in the project settings is using a new enhanced input component, which is based on this type. So we know that this player input component input here points to an object of the new enhanced input component type, but it's in the form of a uInput component. So that means we have to cast it to the new enhanced input component type. And again, taking a look at the third-person template project, if we go to setup player input component, we see that that's exactly what we're doing. We're casting the player input component to the enhanced input component. Now it's using cast checked, which is like cast, but it also asserts that the cast will succeed. If the cast fails, cast checked can actually crash the game for us. Now, you might think that intentionally crashing the game is a bad idea, but in this case, it's good because if our cast to this enhanced input component type fails, we don't want to continue the game we want the game to crash so we can come back and see what's wrong. And of course, they use that trick again where they declare this pointer in the if statement and initialize it by casting player input component to U enhanced input component. Now that means we need the header for this, and I can just scroll up because here in the third person template example, we have enhanced input component here. So I can copy that include, and up here, I can paste in enhanced input component. So we need to cast our player input component to an enhanced input component. And since we're no longer using the old system, I can either remove this line or just comment it out and move it out of the way. So let's cast player input component to an enhanced input component. So we can say if, and we can declare the variable here, U enhanced input component. We can call it enhanced input component. And we can initialize it, and we'll use a cast, but I'd like to use cast checked. I think that's a good idea. We'll crash the game if the cast fails. Now we're casting to U enhanced input component, and the value we're casting is simply the player input component we already have access to in this function as an input parameter. So we'll pass that in, and now our if statement has this local variable inside of it. Now in the old way, we would call bind access on the player input component, but the enhanced input component has its own function that we can use to link up our move function to our move action. Remember, we created a variable move action here. It's a U input action, right? So here's how it's done. We take our enhanced input component pointer and we call bind action on it. In the old way, we had axis and action mappings, and in the new way, there's only bind action. Now, the first input to bind action has to be a U input action. We have that. It's called move action. And we still need to remember to set this in the blueprint. So we'll pass in move action, and we're still getting that red squiggle. So there's something that we need here. And if we look at the third person template project, we see that it includes component/input component.h. If I go ahead and include that here at the top, we'll put it right there. Then we can now see the next input parameters, and the next one we see is eTriggerEvent. Now this is an enum, we can tell because it's prefixed by E. And if we type eTriggerEvent with the double colons, we have all the options. These are all states that our action can be in. It can be canceled, completed, none, ongoing, started, or triggered. Now we want our move function to be called when this action is triggered, so we're going to choose triggered. And the next input is just a U object called object. Much like we did in bind access, we can use this as this is the object we're concerned with calling a function on. And next, we see that we can pass in a function name. We can also pass in the address of a function. That's what these T method pointers are. They're wrappers for function addresses. So we can use the address of operator, and we can use our new move function, a bird move. We need to use the class name and the scope resolution operator that fully qualifies that function name. So this function is going to bind our move callback to our move action. So this wasn't something we needed to do in Blueprint because that auto-generated event IA move in Blueprints is just automatically linked. But if we want our own custom C++ function linked up to our input action, we have to do it this way and set up player input component. So that's the last piece of the puzzle. We should be able to compile and test this out. So I have my editor closed. I'm going to go ahead and compile, and we have a successful compile. So now I can open up my project, and I'll go ahead and open my blueprint, and we see that nothing's linked up here, so none of this matters anymore. I'm going to go ahead and remove all those nodes. And again, we have to remember to select BP bird self, and we have our bird mapping context. We already set that. And we have our move action. This is an input action, and we can choose our IA move. That way, that pointer in C++ will be valid. And it needs to be valid because we're calling bind action, specifying that move action variable. and this line will link up our move function to it. So if everything works, we should see our UE log printed to the screen. So we can test this by, once again, dragging in a bird pawn. We know that auto possess player is set to player 0, so we should automatically possess it. And if we show the output log, I'm going to dock it in the layout here and press play. Then I can click in the viewport and press W, and there's our message. So now we're using enhanced input, and we're calling our move function in C++ thanks to binding it to our input action. And that only works because we added our bird input mapping context through the enhanced input local player subsystem. I know it's kind of complicated, but this really allows us to expand and make our game better. Now, again, I could use the console command show debug enhanced input. And as soon as I do that, now when I press W, I can see that action is triggered. I can see how many seconds it's been triggered, and we see a true or false value based on whether or not we're triggering that input action. So this is a lot to set up, but now that we've set it up, we can easily expand this. We can add more input actions, we can add modifiers or triggers to them, and our input mapping context can take any number of input actions, and all we need to do is go through the steps to link up our C++ functions to those actions. And in the next video, we're going to add some more complex behavior to a pawn. So we'll learn more complex things that we can do with our input actions in our input mapping context. So great job. Thank you for watching, and I'll see you in the next video.